Howdy, folks. So, I figured I should explain how a bend actually works, just bending into a new plane. So essentially, we got to know a couple things. Unit length, that's the length from your center of rotation or your hand to the head, like essentially the length of your tether. That's like important for isolation. You move your hand a half unit length around the tether to get it to isolate, right? Or for a pendulum, to make it a point isolation, you would move your hand over it in a unit circle, like that. So this distance, this hand path, will depend on the length of your tether, but a unit circle is one tether length around your poi, essentially, or in the other direction, a static spin. So if you understand that idea, and then floats or extensions, that's the next kind of idea you'll have to understand. If you got those two things, this shit's real easy. So think of it, we're going to start bending from the wall plane to this wheel plane, and we're going to pay attention to this. So this is the plane I intend to be in. This is the plane I'm currently spinning in. There's a point where the plane I'm in and the intended plane will have a shared axis. That's the point at which I will rotate my hand a quarter. Well, depending on the degree of bend, if we're bending 90 degrees, we'll rotate our hand 90 degrees so that its center of rotation is now on that new plane relative to where the head will be. And we do that while the poi is floating up along the shared axis. As soon as the poi is on the shared axis of my plane, in my intended plane, I kind of let it float. I kind of do a small extension if I'm in horizontal. And while it's floating up, I'll rotate my hand, that unit circle, into my new plane, and then flick to get it going again. So I'll just demonstrate that. Spinning, here's my plane. This is my new intended plane. Right here, where my head is, now, that's the shared axis. When the head gets to that point, I'll extend slightly and rotate my hand. Boom. Now I'm in this new plane. I can do the same thing at the same point, and come right back to where I started. If I do that, I'm isolating that point. So I bend, go 360 degrees, and bend again, then I've isolated my bend point. It always ends up in the same place. But we can do things like this. I'll bend, and then instead of waiting for it to float up and bending at my same point, I'll wait for it to float down, and again do the same idea, but while it's falling, and I'll link this bend, this plane to this plane through a 180 bend. So over the top and down, or while it's falling down, I bend to this one. While it's rising up, I bend to this one. So we'll bring it back to the front, and we'll consider bending into a horizontal plane. So this here is my shared axis between horizontal and my current plane, right? So as the poi's moving this way, I'll kind of float it, move my hand, and now I'm in my new plane. So from this end, we'll do the same thing. As it's moving this way, I'll float it and bring my hand down so that I'm in the plane that I want to be in. You can even do this off diagonals, so you can get into your diagonal planes that way. You can bend essentially from any orbit. You could bend into any other orbit if you're clever about it, right? Because this side's bending up, this side's bending down, this side, the top's bending this way, the bottom's bending this way. You could bend any degree. So I don't have to rotate my hand around the head to 90. I could bend to 45. So at this point, I'll make my bend. This will be my new plane. So I'll need to put my hand right here. I can do the same thing on this side. And so now again, I'm creating an isolated bend point right here by going 360 degrees each time before I bend again. So bend 360, bend 360, bend 360. I can make a triangle. Instead of making this, I can make a triangle by bending on the opposite corner and then bending again on the opposite corner. You'll discover, because this is a multiple of 180, because each of these bends occurs at 180 degrees from the previous one. So we have this, a 180, another 180, and another 180. That's three 180s. We can kind of simplify that down to an odd number. Odd numbers are always going to be multiples of 180 when you're linking bends like this. So what happens when we get 180? It reverses. So you can iso bend, or you can link these bends by bending on the opposite edge of the orbit each time. You can also isolate and then link. So you end up with a pattern like this. Isolate, link, isolate, link, and then isolate, link, isolate, link, right? So this four-lobed toroid. This four-lobed toroid is a really great tool for drilling your linked bends on the outside and for drilling iso bends on the outside. Excuse me. You can also bend iso from the middle or link any way you want. But every time I make a bend, what's happening is my center of rotation is moving 1 unit length, rotating 1 unit length around the shared axis of the two planes, the plane I'm in and the intended plane. Hopefully that's pretty clear. Play around with it, and I'm pretty confident you'll see what I'm saying. It's like there's a feel to it. And if it's difficult at first, make sure you exaggerate, excuse me, exaggerate the extensions, and that will give you more time to get your hand. If you try to just do it in no time at all, you can do it, but if you extend it, it buys you some time to get your hand into the position it'll need to be in for that new plane. So have fun with that, mess around, see what you come up with.